Strategies for schema design. Now we have the first one is top-down strategy. It starts with a schema containing high-level abstractions and then apply successive top-down refinements. The second one is bottom-up strategy. Start with a schema containing basic abstractions and then combine or add to other abstractions. The third one is inside-out strategy. It starts with central set of concepts and then spreads outwards by considering new concepts. Okay, and the fourth one is mixed strategy. It uses a combination of top down and bottom up strategies both. A third phase is choice of DBMS. There are some of the factors which affect this choice of DBMS, like technical factors, economic factors, and organizational factors. Technical factors are like the types of DBMS we can use. There are different types of DBMS, like relational DBMS, object relational DBMS, object DBMS, etc. Economic factors are like acquisition, maintenance of that, training, and operating costs. And the organizational factors are familiar to staff with the system, like that systems. And it also has the availability of vendor services. Our next phase is data model mapping. This is also known as logical database design. What we does in this, we just transform the conceptual schema from the high level data model to the data model of chosen DBMS. Like the high level data model is used in phase 2, so we convert the high level data model to the data model of the chosen DBMS. Now we can start this phase after choosing a specific type of DBMS. Our fifth phase is physical database design. During this phase, we design specifications for the stored database in terms of physical storage structures, record placements, and indices, etc. This corresponds to designing the internal schema, the internal structure, in the terminology of the 3-level DBMS architecture. Our next phase is phase 6, which is data system implementation and tuning. During this phase, the database and the application programs are implemented, tested, and eventually deployed for real-time services. Various transactions and applications are tested individually and then in conjunction with each other. When this typically reveals opportunities for physical design changes of what all is needed to improve that, and data indexing, reorganization of the elements, and different placements of data. Now in this, what is tuning? Tuning is an ongoing activity. It's a part of system maintenance that continues for the life cycle of data. This means as long as the database and applications keep evolving, keep changing, and the performance problems are detected through it. Thank you. That's it for today.